On September 16, 2023, earthquake detectors around the world started picking up a strange vibration. It was a deep rumble, a seismic wave, but one that didn't look anything like a regular earthquake. The noise was made up of just one frequency, like the sound that comes out of a tuning fork. And it kept ringing for 9 full days. Earthquake scientists had no clue what they were looking at, so they spent nearly a year tracking down the source of this planet-wide shakeup. And what they found is something we've never seen before, but something that's bound to shake up our planet again. After this mysterious signal showed up on detectors around the world, dozens of scientists from 15 different countries teamed up to track down the source, or what they called the unidentified seismic object. Given how long it took for the vibration to reach each one, scientists could estimate how far away that station was from the source. They used that data to trace the event back to somewhere in East Greenland, and that's where they found their next clue. On the same day the mystery signal started, sea level gauges in East Greenland recorded an absolutely massive tsunami. It was around 4 times taller than Niagara Falls, making it the tallest recorded wave on Earth since 1980. So it seemed pretty likely that this massive wave had something to do with the mystery signal. But before scientists could figure out what, they had a new question to answer. What had caused this monstrosity of a tsunami? To solve this puzzle, the team of scientists turned to satellite images and seismic data to piece together the events leading up to the tsunami. And what they found was, on the day that the signal began, a colossal chunk of land broke off a mountain more than a kilometer above the water. On its way down, it shattered a glacier, sending 25 million cubic meters of rock and ice, enough to fill 10,000 Olympic swimming pools, crashing into a nearby fjord. And this wasn't just any rock slide. It was really a perfect storm. It had all that extra debris from the shattered glacier, plus an icy slope acting like a natural slip and slide. All that energy got funneled into a narrow gully. So by the time the rocks and ice splashed down into the fjord, they packed a massive punch and kicked up an absolutely enormous wave. So scientists finally had a picture of what happened the day the signal began, but that still didn't answer the question of what caused the noise. Because the landslide was over in minutes. How could it explain a signal that went on for 9 days? There was only so much scientists could figure out from the data they happened to have on this event. So to piece together the finer details, they created a simulation that would let them model how the whole disaster unraveled. But to do that, they needed funding, and so do we. So let's tell you about ours.
Thanks for watching this SciShow video. In fact, thank you for watching all of our SciShow videos. Let us know in the comments if you've been around for all 13 years. But 13 isn't enough. We want to keep filling the internet with human-made, well-researched, and fact-checked videos. But we can only do that with your help. We hope you've enjoyed watching and maybe learned a fun fact or two along the way. And for more fun facts, check out our new SciShow postcards. Each one contains a link to a secret video that you can only get by ordering a postcard. To help keep SciShow going for another 13 years, get your SciShow postcards at complexly.com/postcard. And do it now because they're only available until February 3rd.
Now, back to the researchers and their landslide model. Simulating the details of the event was a great call, and it turned up something really surprising. Instead of crashing and dissipating like a typical tsunami, their wave got trapped between the walls of the fjord. And for days, it sloshed back and forth, just like a wave between the walls of a bathtub, if that wave were about 60 stories tall. Now, a wave like this isn't unheard of. It's called a seiche, and you get one now and then in bodies that are partly or fully closed off, like lakes and harbors. They can happen anytime some force, like a strong wind or a tsunami, pushes a bunch of water up against a shoreline. When the thing doing the pushing lets up, all that water slides back and bounces off the opposite shore. And this kind of wave can keep going for hours or days until it gradually loses its energy and dies off. The SciShow in their simulations bounced off opposite shorelines every 87 seconds, and that's when scientists realized they might have just cracked the case. Because one cycle every 87 seconds was awfully close to the period of the mystery signal they detected the day of the landslide. To check if their simulation was really capturing what had happened in the real world, scientists looked at a few other lines of evidence, and everything seemed to line up. The sloshing wave moved in the same direction as the waves detected at the monitoring stations. Small variations in the real signal lined up with the tidal cycles in the fjord, and the simulated SciShow petered out at about the same rate as the real signal. So there was their answer. As best anyone can tell, a tsunami trapped in a fjord shook our whole planet for 9 days. Nearly a full year after the signal was first detected, the case was finally closed. But it wasn't all happily ever after once scientists got their answer, because they realized that this whole thing wasn't just a random catastrophe. The SciShow that shook up our planet was like the final step in a Rube Goldberg machine that got going decades ago. It all started with climate change and some unusual configurations of geology. See, this spot has a whole mountain leaning on a glacier that had lost tens of meters of ice over the years. Finally, it got so thin that it could no longer hold up the mountain. That's when a massive chunk collapsed, kicking off the tsunami and then the SciShow, which means that ultimately, this planet-wide seismic signal was triggered by climate change. Scientists have never detected something like this before in Greenland, but as more glaciers melt, more landslides are inevitable, and possibly more global shakeups. So this mystery signal turned out to be more than a geological puzzle. It was a signal that we're living in a world that's changing in unpredictable ways. As we get better at cracking the cryptic messages our planet is sending us, it's also up to researchers, as well as the rest of us, to listen to what it's saying.